This is a video lesson for Chapter 12, Lesson 1, which is the first lesson of trig. For this lesson, you will need a calculator, so make sure you have one out and ready. So, what is trigonometry, which is the unit that we'll be doing for the whole rest of this semester? Trig is the branch of mathematics dealing with the relations of the sides and angles of triangles and with the relevant functions of any angles. So what that really means is we are going to be doing a lot of investigations regarding angles because a lot of times what you can do is make any angle into a triangle and use these properties. So with that said, one of the big things that we're going to have to be able to do is deal with a right triangle. I know you have some experience seeing this before, but this should be good review for you. We have our right triangle. We know that because we have a right angle here in the bottom corner. Across from your right angle is the longest side of your right triangle, which we call the hypotenuse. Given what angle we're talking about, because there's two different angles we could be talking about besides the right angle, we could be talking about this angle over here, or we could be talking about this angle over here. Given the angle that you're talking about, you're going to name the other two sides. So you can tell by this picture, we've labeled this bottom corner as our given angle of interest. Directly across from that side, or from that angle, is called the opposite side. And then the third remaining side, the side that's actually touching that angle that we're interested in, that's called the adjacent side. We usually abbreviate these by their first letter. So this is the O side, the A side, and the H side for when we're talking about trigonometry. Important theorem that you should know is Pythagorean theorem. It's expected that you already know that and can use it. In the Pythagorean theorem, we call the hypotenuse side side C, and then it really doesn't matter what you call the other two sides. You can call one side A and one side B. But the formula just says A squared plus B squared equals C squared, and you've heard that one a million times. So the first three trig functions that we're interested in are sine, cosine, and tangent. You have probably heard this referred to as SOHCAHTOA. So the S for opposite over hypotenuse, which is this formula right here. Ka, the C for cosine, and the A and H for adjacent over hypotenuse. And then TOA, T for tangent, O for opposite side, A for adjacent side, opposite over adjacent. So you see these three formulas, the sine, cosine, and tangent formulas, all contained within that little phrase or acronym SOHCAHTOA. So let's get into what these problems are actually going to look like. We're going to have a triangle, and we're going to be asked to perhaps find the trig functions for a particular angle, and then eventually we'll be asked to use trig to help us find some of the missing angles and sides of the triangle. So for this question, they say find the sine, cosine, and tangent of the given angle. This symbol is called theta, and that is telling us that angle A is the angle that we're interested in. So we need to go and find sine of theta, cosine of theta, and tangent of theta. Well, directly across from the right angle, we've learned to call that the hypotenuse, the H side. Across from our angle of interest, the theta, that is our opposite side. And then the third side we're going to call the adjacent side. So sine equals opposite over hypotenuse, which is going to be equal to, well, I don't know what that third side is. I know that we have a side of 6 and a hypotenuse of 10. So what I'm going to have to be able to do before I go and fill any of this in is I'm going to have to use Pythagorean theorem. This side right here, which we'll just call side A, because it's across from angle A, we don't know what that is. we know that a squared plus 6 squared equals 10 squared. Since we know that the hypotenuse is 10, the other side's 6, and we're trying to figure out what this side A is. So I am going to simplify and get a squared equals, a squared plus 36 equals 100. I'll subtract 36 from both sides and get a squared equals 64. We'll square root both sides. Technically the answer is plus or minus here, but there's no negative lengths of triangle sides, so it's just going to be a equals 8. Now that I know that this side here is 8, I can fill in for sine. The opposite side's going to be 8. The hypotenuse is going to be 10. And that simplifies to 0.8 or 4/5. We'll just write it as a decimal for now, 0.8. The cosine is given by adjacent over hypotenuse. Well, now that we have all three sides, this isn't going to be very hard. Our adjacent side was 6. Our hypotenuse side was 10. And that's going to be 0.6. The tangent is opposite over adjacent. The opposite side here being 8. The adjacent side here being 6. And 8 over 6. We can do that in our calculator if we want, or if you just know it. That's going to be 1.33. And there we go. We've got our 3 trig functions for the given angle theta. Moving on to example 2. Example 2 asks us to do the exact same thing to find the 3 trig functions for this angle in the bottom left corner over here. Okay. Well, once again, we kind of figured out we want the 3 sides if we're going to be able to do something like this. So let's go find this third side C. Well, some of you know your Pythagorean triples, and if you know that, then you're going to know this answer is 13. But if you aren't sure, let's do it. C squared equals 5 squared plus 12 squared, which is going to be C squared equals 25 plus 144. C squared equals 169. Square root both sides, ignore the negative because you can't have a negative length, and we're going to get C equals 13 like I said. Okay, now we've got our 3 sides, and we're going to list it out. Sine of theta, cosine of theta, tangent of theta. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Across from theta, that's my opposite side. Across from the right angle, that's my hypotenuse side. And the third side's called the adjacent side. So our opposite in this problem is 5. Our hypotenuse is 13. So we've got 5/13. This problem, we'll just leave these in simplified fraction form. The problems on the quiz and test and homework will specify what they want, whether they want it as fractions or decimals. For this, we're going to go adjacent, which is 12. Hypotenuse is 13, so we'll just leave it as 12/13. And then tangent, opposite being 5, adjacent being 12, and we'll just leave that as 5/12. And those are our 3 answers. Now, there are 3 other trig functions to be interested in here. There is cosecant, which is the flip of sine. Secant, which is the flip of cosine. And cotangent, which is the flip of tangent. So the same ratios, but flipped. A lot of people get these confused because they want to think for cosecant to flip cosine because they both start with a C, but that's not true. Same thing with secant and cosine. It is true for tangent and cotangent. So you're going to have to work to keep those straight in your head. So now example 3 asks us to find all 6 trig functions. Well, really, it's the same problem. We've got to find the first 3, and then flip them, and you'll get the other 3. So we're going to want sine theta, cosine theta, tangent theta. And once we get them, it's going to be pretty easy to go get cosecant theta, secant theta, and cotangent theta. So I need to go find that third side. So this is going to be 8 squared plus mystery, b squared, equals 17 squared, just using that Pythagorean theorem. 64 plus b squared equals, and I'll go to my calculator on that one and do 17 squared, which is 289. I'll subtract the 64 and get b squared equals 225. And when I square root both sides, I'm going to get b equals 15. Okay, so 15 is going to go here. Sine is opposite over hypotenuse, which will be opposite over here. So 15 over 17. This must be the adjacent side then. So cosine is adjacent over hypotenuse, which will be 8 over 17. And then tangent's opposite over adjacent, which will be 15 over 8. Now, all you do for the other 3 is just flip them. 17 over 15, 17 over 8, and 8 over 15. And that's it. Once you know 3, not hard to get the others. Now, moving on to example 4, which is using trig to go and get some of the sides. So this says use the given angle to find the missing side. We're going to go and solve this whole triangle so that you're ready for that. They really wanted you just to get x, but I know your homework's going to have you solve the whole triangle. So let's do that and end on that. So the first thing that we are going to do is just write what we know the other angle is. We know that this angle must be 30 because the 3 angles have to add up to 180. Right here, you know you got 90. Then you know you've got 60. So you've got 150 of the 180 degrees in a triangle, and 30 is all that's left. So that third side's going to be 30. Okay? Now, what we are able to do with a problem like this is if we're trying to go find this side, let's pick an angle that's interesting to us. I would say 60 because it was given to us. If 60 is the angle that we're interested in, then that makes x the adjacent side, and it makes 11 the hypotenuse because it's across from the 90. Well, if I know the adjacent and hypotenuse, A and H are the things I'm interested in, that's the ka in SOHCAHTOA. That's cosine, A and H. So cosine of 60 degrees, the angle I'm interested in, should equal the adjacent over the hypotenuse, which is x over 11. Well, cosine 60 is actually something I can get on my calculator. And I can get x alone by multiplying both sides by 11. So I'll multiply by 11, multiply by 11. I'm ultimately going to get x equals 11 times cosine 60. And we can do that on our calculator. Really important thing that we need to do on our calculator is make sure we're in the correct mode. So in the upper left-hand corner of your calculator, one button in, you're going to find a button that says mode. And about 3 clicks down, you're going to see a highlighted thing that either says radian or degree. We want to make sure we're in degree mode for this problem. So I'm going to click on degree and just make sure my calculator's in degree mode. Okay, we'll be switching between modes throughout this chapter. I'm going to quit out of that menu, hit second mode, second quit. Just making sure I'm in degree mode, okay? And now I'm going to type in 11 times. I'm going to find the cosine button, which is 2 above 8. Press the cosine button, and then put in 80. So, or sorry, 60. So it's going to say 11 times cosine of 60, and I'll hit enter. And I should be getting back, if I did it right, I should be getting back 5.5. And that's our value for x. Now, when they ask us to go and solve the whole triangle, that leaves us with one side remaining because I've already gotten all three angles. I've already gotten 2 of the 3 sides. So we'll call this side y, or actually let's call it side little b. Well, now I'm down to a Pythagorean theorem problem. I can say that 5.5 squared plus b squared equals 11 squared. 5.5 squared is 30.25 plus b squared equals 121. I can take that 30.25 off of that 121 and get b squared equals 90.75. Square root both sides, and we get an answer of b equals the square root of 90.75, which is approximately 9.53. And now I've solved the whole triangle. I know what all 3 sides are and all 3 angles are, and the problem is over. And that sums up our lesson. First finding these different trig functions, and then finally using the trig functions to be able to solve a triangle. Now you'll have a little activity to get better at this, but this is the end of lesson 1.